Hey there, today we're talking about error handling in Python. I have a function that divides a by b and prints out the result. So if I divide 10 by 2, I see 5. Now what happens if I divide by 0? Python throws an error called zero division error, and it's basically saying this line that you executed is dividing by 0 and you can't do that. So the way that error handling works is that we use these things called try except blocks, and we put the code that could potentially throw an error in our try block. And in the except block, we can catch the error that was thrown. For now, I'll just print an error occurred. And we'll talk more about this in a second. So if I run this now, our program is not crashing because we are handling that situation. So if I have more lines after this, so let's say I will divide by 5 after this, then that next line is executed just fine. And you can try to see if we had an error, you would see that nothing after this would get executed because our program would crash. Now let's talk a little bit more about this except block. Right now, the error that is caught is very general. So if there was another situation, for example, if I divide by a letter, then again I see an error occurred. So the user really is not getting useful information about, okay, how can I go fix this so next time I don't run into this error. So if I let the error actually be printed out, so I can catch it here. So for now, let's just catch it as an exception, and I'll talk about this in a second. And I will print out what the error actually is. And let's print it out for both of these. So the first one is a division by 0, and the second one is saying it's a type mismatch. So basically we can't divide an integer by a string. Now each of these have their own name. So if I were to get rid of these try except blocks and just let these actually throw an error. So that first one was a zero division error. The second one is a type error, which means we can specifically catch these separately and provide useful messages to the end user. So let's go back to our try except, and instead of catching an exception, which is a broad category, I will catch a type error and I will tell the user there was a type mismatch. And I will also, for each case, print the error so the user can see exactly what error the application threw. And then I have one more case. So this one was zero division error. So for this one, I want to tell the user you cannot divide by 0. And I will also print out the issue here. So now if I run the whole application all together, you see that I'm providing very useful information to the user so they know what went wrong, and also the program is not crashing, so every line is getting executed all the way. Now there is a couple of more details about this. First, let me show you where do these exception categories come from. So there is a lot of them, and you really don't need to memorize any of this. So, and I will share this link in the description, but these are the error categories that you could catch, and not all of them are really relevant to every piece of code. So for example, right now, we only cared about this one, which goes under the arithmetic errors, and we also caught the type error down here. Now, if you catch something like exception, as you can tell, everything goes under exception. So if you catch it, this parent category, then you're not really sure which one you caught. So everything under that gets caught. Now, if your only goal is to prevent your application from crashing, then it would make sense to catch a very broad category. But you basically get the idea. If you want to provide useful messages to the user, you want to be as specific as possible. Now, there is another topic, I guess another block that we can add to this try except called else, and else occurs if no error happened in your try block. So it makes sense for me to print the results only if no error occurred. So if I run this, this is working fine, and this line of code is only getting executed if no error occurs. And the last one is finally. So finally is the block that gets executed regardless of what happened prior to that point. So I'll just print this line. I'll just program finished. So regardless of if we had an error, so this is the first one, this is the second one, regardless of having an error or not, we see that the finally block is getting executed. The final topic that I want to talk about for error handling is the concept of raising an exception manually. So right now we are dividing numbers, but let's say this was a real scenario where you're dividing a certain amount of money by a certain number of people. So mathematically you can divide by negative numbers, but in that scenario it doesn't make sense to divide by a negative number of people. So for that, up here I can say if b is negative, I want to raise an exception, and I will provide a useful message to the user. I will say denominator cannot be negative. So if I raise this exception, as I'm sure you know, this will not be caught by the type error. It will not be caught by the zero division error. It will be caught down here. So I expect to see that message down here, and I will get rid of this just to not see too many print messages down there. Okay, so if I provide an example where I'm dividing by a negative number, so now this last line saying an error occurred, denominator cannot be negative, which is, so this line is getting executed, and this error is the message that we manually generated. So this raise concept is very useful when you're working on a domain specific piece of code and you want to communicate to the user certain things that Python doesn't consider an error, but you want to tell to the end user that these are the things that we expect you to do, so therefore they can provide the appropriate values. So this is really error handling in Python in a nutshell. You really don't need to memorize any of these error types. As you work in specific domains, your knowledge increases and you kind of know which ones to use, and overall it's a really helpful way of making your application more robust, so to prevent it from crashing if a user provides values that are not accepted. So I really hope that this helped, and if you like this channel, please like and subscribe, and I will see you soon.